Welcome viewers, in this video we'll see the asynchronous 3-bit down counter. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Asynchronous 3-bit down counter. Counter is a device that is made up of flip-flop. So flip-flop is the storage element. It will store the 1 bit of data. So this counter will count the numbers from 0 to n or n to 0. So because of this down counter, it is counting from n to 0. So 3-bit counter. So 2 to the power 3, there are 8 combinations will be there. That is 002 up to 111. But here down counter, so it will count from 111 to 000. So there are two type of counter available, synchronous and asynchronous. Synchronous mean all the flip-flop will receive the same clock pulse. The stages will change simultaneously. But in asynchronous counter, the clock pulse given to only first flip-flop. Second flip-flop is connected with the output from the first flip-flop. Like that it is connected. So the sequence it is not executed in a order. Simultaneously not executed. So that is called a asynchronous counter. Right. So there are 8 combinations starting from maximum to minimum 111 to 00. The block diagram of 3-bit asynchronous binary down counter is shown below. So this is a logic diagram is available. So it is made up of a T-type flip-flop, T flip-flop. There are 3 T flip-flop available, 1, 2, 3. The T input is given as high input. What is the nature of the T flip-flop? If the T input is 0, no change in the present state and next state. Present state and next state are same. If the T input is 1, then toggle. The present state 0 means next state will be 1. Present state 1 means next state will be 0. Right? 1 will change to 0, 0 will change to 1. Right? Here, so high is given, 1 is given. So, for every clock pulse, the output will toggle. The output of the first flip-flop will toggle. That is the nature of the T flip-flop. The T input is 0, no change in the next state. T input is 1, there is a toggle will occur. 0 means 1, 1 means 0. So here we are giving high, logic high. So that every clock pulse, the state will change. For the first flip-flop, the clock pulse is given. So inverted, negative edged clock pulse. We will see what is meant by negative edge. Then second flip-flop, the clock pulse is Q0 bar. This is a Q0, output of the first flip-flop. Q0 bar is the complement. Q0 bar is connected as a clock pulse of the second flip-flop. Right? First flip-flop complemented output is connected as a clock pulse of the second flip-flop. Similarly, second flip-flop complemented output Q1 bar is connected as a clock pulse of the third flip-flop. Right? So this flip-flop output is executed every clock pulse. The second flip-flop clock pulse is executed based on the Q0 bar value. Third flip-flop output is based on Q1 bar value. Right. So this is connected. This is also inverted. Negative edge triggered pulses, clock pulse are given. What is meant by negative pulse and positive edge trigger? Let us consider this clock pulse. That is, this is 0, this is 1, this is 0. Right. So from 0 to this is the clock pulse. But here 2 edges are available. So this is called as a positive edge. This is called negative edge. Positive edge triggering. This is called negative edge triggering. That is from lower to higher. This is rising edge. This is called from 0 to 1. That is called a positive triggered, positive edge triggered pulse. From 1 to 0, this edge is called negative edge triggered. The signal goes from 1 to 0. Right? So 0 to 1 rising means it is called positive edge triggering. 1 to 0 means it is called falling edge. It is called a negative edge triggering. So here we are connected with the complement. So every falling edge, negative edge, the state of the flip-flop will change. If it is connected directly without input, without inverter means every rising edge, positive edge, the state of the flip-flop will change. here it is connected with complement, so every negative edge the flip-flop state will changes, right? So based on that we will see the output, right? So this is positive edge, negative edge. In this flip-flop it is connected with negative edge, inverter. Now we'll see the clock pulse and the output waveform. So this Q2 is the MSB, Q0 is the LSB, right? LSB and MSB. Now we'll see the clock diagram and 8 possible output of this 3-bit down counter. So this is a clock pulse applied. 1, 2, 3, 4 up to 8 pulses are available, right? So this is the falling edge. This is the rising edge. 0 to 1. When the clock pulse changes from 0 to 1, rising edge. 1 to 0, falling edge. So every falling edge, every negative edge, the state of the flip-flop will change. So initially it is 0. Q0 is 0. Q1 also 0. Q2 also 0. Right? Initially all are zeros. So during this, the first flip-flop, the clock pulse is applied. The clock pulse is applied to first flip-flop. So during this negative edge, 0 changed to 1. This is rising edge. 0 to 1. This is rising edge. This is the falling edge. So during this falling edge, 1 changed to 0. This is higher, 1. Now changed to 0. During the next negative edge, 0 changed to 1. During next negative edge, 1 changed to 0. During this negative edge, 0 changed to 1. Now during this negative edge, 1 changed to 0. Here 0 changed to 1, again 1 changed to 0. So every negative edge, the state of the clock pulse changes. 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, like that. 0, 1, 0, 1, like that changes, right? So the clock pulse is connected to first flip-flop. So every negative edge, the state of the flip-flop changes. Now this is the Q0 output. This Q0 bar, this is Q0 bar, inverted. 0 means 1, 1 means 0. This Q0 bar is given to the second flip-flop. So based on this signal, the state of the second flip-flop will change, right? So for the first flip-flop, this is the clock pulse. For the second flip-flop, Q0 bar is the clock pulse. The output of complemented output of first flip-flop is given as a clock pulse to the second flip-flop. So here also during every negative edge, the state of the clock pulse will change. So this is 0. This is from 1 to 0. So this is the falling edge. This is rising edge, 0 to 1. This is the falling edge. This is rising edge, 0 to 1. This is falling. This is falling edge. This is negative edge. These are all negative edge. So during this negative edge, 0 changed to 1. So this is positive trigger, so no change. Again, in the next negative trigger, negative edge triggering, 1 changed to 0. This is positive, so no change. During the next negative edge, 0 changed to 1. Here it is positive edge, no change. So during next, it is changed from 1 to 0. So every negative edge triggered, the state is changes. 0 to 1, 1 to 0, 0 to 1, 1 to 0 during here. This is not applicable. This is applicable when the clock pulse is directly connected. Right? This is called rising, 0 to 1. This is falling, 1 to 0. Right? So every negative edge of this Q0 bar, Q1 output is changes. Right? Now this is Q1 bar complement. 0 means 1, 1 means 0, because Q1 bar is the clock pulse for the third flip-flop. So this is the third flip-flop output, that is complement of second flip-flop output is given as clock pulse. So here also every during the falling edge, 1 to 0. This is rising edge, 0 to 1. This is falling edge. Similarly, at this point the falling edge will be there. So during this falling edge, during this negative edge, 0 changed to 1. This is rising edge, so no change. When the next negative triggered, 1 changed to 0 until next negative edge, right? So during these two positions, 0 changed to 1, 1 changed to 0. Right? Now we got the output of Q0, Q1 and Q2. From that we need to see whether we have got the 8 different stages of output. Right? So this is the clock pulse 1, 2, 3 up to 8. There are 8 stages. This is the count. Initially 0, 0, 0. Now see this 1, 1, 1. This is also 1. Next 1, 1, 0. This is MSB, that is LSB. 1, 0, 1. 1, 0, 0. Then 0, 1, 1. 0, 1, 0. 0, 0, 1. Finally again 0, 0. So we got all 8 stages of 3-bit binary. 3-bit, there are 8 combinations. 8 combinations are now clearly available. Right? So this 1, 1, 1, 1, 1, 0, 1, 0, 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0. Now we'll see the description of what we discussed. The description is available. Now we'll see the description. The block diagram of 3-bit asynchronous binary down counter is similar to the block diagram of 3-bit asynchronous up counter, but the only difference is that instead of connecting the normal output of one stage flip-flop as a clock signal for the next stage flip-flop, connect the complemented output of one stage flip-flop as a clock pulse for a next stage flip-flop. Right? If you connect Q0 as a clock pulse, it acts as a up counter. Q0 bar as a clock pulse, it will act as a down counter. Complemented output goes from 1 to 0, is same as the normal output goes from 0 to 1. Right. Now see the remaining description. Assume the initial status of the flip-flops are 0, 0, 0. The Q2 is the MSB, Q0 is the LSB. That also we already discussed. Now we'll see the truth table. So this is the clock pulses. Initially 0, 0 mean all the values are 0. 1, 2, 3. So this 1, 1, 1. Then 1, 0, 1, 1 down counter. So we are getting the maximum value first and minimum value at the last. 0, 1, 1. 1, 0, 1. 0, 0, 1. 1, 1, 0. 0, 1, 0. 1, 0, 0. So we need to read from like this. 0, 0, 1. 0, 1, 0. 0, 1, 1. 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1. Right. Here Q0 toggled for every negative edge of clock pulse because first flip-flop is connected with the clock pulse. So every clock pulse, the negative edge of the clock pulse, Q0 changes. Q1 toggle for every Q0 that goes from 0 to 1, otherwise remained in the previous state. Right. So the Q1 is based on the Q0 value. Similarly Q2 and others. Q2 toggles for every Q1 that goes from 0 to 1, otherwise remained in the previous state. Right. So Q0 based on clock pulse, Q1 based on Q0 value, Q2 based on Q1 value. The initial status of the T flip-flop in the absence of clock pulse is 0, 0, 0. This is decremented by 1 for every negative edge clock signal and reaches the 8th same value at 8th negative clock pulse. Start from 0, 0, 0 and it is decremented. 1, 1, 1 decremented slowly and finally at the 8th negative edge again it will goes to 1, 1, 1. So in this video we discuss asynchronous 3-bit down counter 1, 1, 1 to 0, 0, 0. 3-bit there are 8 combinations. We discussed the logic diagram, that is using the T flip-flop. Then the timing diagram, output of each flip-flop. Then the truth table and other description. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.